So when we're studying trigonometry, we are typically studying right triangles and some calculations, some ratios that we use with those. So if we have a right triangle, we know it's a right triangle because we have that right angle symbol in the corner. There are two other angles that are acute triangles, or acute angles rather, and the usual symbol that people use for one of these other two is going to be the Greek symbol theta, which looks like a circle or an O with a line drawn through the middle. And then from there, we need to talk about the lengths of some sides. So let me label some sides here. Here's our right triangle. And in our right triangle, the side that does not touch the right angle, which ends up being the longest side, that is the hypotenuse. And then these two sides that make up the right angle, those are called legs. But when we're dealing with trigonometry, we give them a more specific name. So in relation to this angle here, theta, we have these two sides. There is this one, which is straight across from our angle, and that one we call the opposite side. And then we have the other side here, which touches our angle theta, and we call that the adjacent side. So with trigonometry, we have a right triangle. So one of our angles is a right angle. And then we will describe the triangle with regards to the side lengths and this angle theta. So to start with, we're going to talk a bit about the three main trigonometric functions. There is the sine. Sine is spelled S-I-N-E, but we abbreviate it S-I-N. And the sine of an angle is always equal to the length of the opposite side divided by the length of the hypotenuse. Cosine is another one of those main three trigonometric functions. It's spelled C-O-S-I-N-E, but we just use, again, the first three letters. So C-O-S is for cosine. So we have the cosine of our angle, which again is that Greek letter theta. So the cosine of theta, when we calculate that, that is going to be the length of the adjacent side divided by the length of the hypotenuse. And the last of the three main trigonometric functions is tangent, T-A-N-G-E-N-T, but again, we use the first three letters to abbreviate. So it's the tangent of theta here. And the tangent of theta is the length of the opposite side in our right triangle divided by the length of our adjacent side. There is an acronym that we tend to use when we go through and work with these three trigonometric functions. The length of the opposite side, people usually just call that O for opposite. And the length of the hypotenuse, people use H for that. Similarly, the length of the adjacent side, people often label as just A. The hypotenuse, again, is H. And then here we have opposite side divided by adjacent side, so that would be O over A. And if you take the first letter of each one of these trig functions, and then each one of those three letters that correspond with each one of those three functions, you end up with this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent, that's opposite over adjacent. So this is that phrase SOHCAHTOA that we use so that we can remember what trig function goes with what ratio. So really this is three separate equations. Sometimes you'll see people split those into thirds. So it's SOH, sine is opposite over hypotenuse. CAH, the cosine of our angle is adjacent over hypotenuse, and TOA, tangent is opposite over adjacent. So that is SOHCAHTOA. In addition to these three main trigonometric functions, there are three reciprocal functions. And the reciprocal of sine is the cosecant. Cosecant is spelled C-O-S-E-C-A-N-T, but we can't use the first three letters because the first three letters are C-O-S, and we've already used those for cosine. So the cosecant abbreviation is C-S-C. If you know that sine and cosecant are reciprocal functions, and you've memorized SOHCAHTOA so that you know that sine is opposite over hypotenuse, then you know that the cosecant is going to be equal to the reciprocal of our sine. Sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite. The reciprocal of cosine is secant, S-E-C-A-N-T, but again, we abbreviate it with the first three letters. We haven't used those three, so we can use those now. And because they're reciprocals, we can just use the ka part of SOHCAHTOA to figure out what the secant is equal to. Cosine is adjacent over hypotenuse, so secant would be the reciprocal of that, hypotenuse over adjacent. And tangent, its reciprocal is cotangent, C-O-T-A-N-G-E-N-T, but again, we use the first three letters. We haven't used those before, so we can use them here. And if you know that the tangent is opposite over adjacent, and you know that the reciprocal of tangent is cotangent, you'd be able to determine that the cotangent is adjacent over opposite. So that's a quick introduction of our trigonometric functions. We need to be able to look at our right triangle and determine which of these sides are labeled which. Our hypotenuse, that's always the longest side, and it does not touch the right angle at all. And then one of our acute angles will be listed with a variable. Often it's this Greek letter theta. Straight across from that is the opposite side, and then the leg that it's touching is the adjacent side. And then from there we used SOHCAHTOA typically to remember the first three, the three main trigonometric functions, and then we have our three reciprocal functions which we can build off of SOHCAHTOA from there.